Things get uglier. I just pulled out the spark plug and I see a few things that bother me. The first thing is the spark plug was barely tight. I was able to unscrew it with my fingers. Second thing is it's a brand new spark plug. It shows like zero evidence that it's ever been run. So why would somebody put a brand new, what looked like a brand new air filter, right? Looks like a brand new air filter in this thing, brand new spark plug, and then not even run it? You hear that? Listen closely. You can almost hear the people screaming at the video screen telling me to do a compression test. Well, all right, I'm going to do one. So anyways, I was just going to put the recoil assembly back on here, and I remembered about that screw that was stripped out. Well, lo and behold, I can tell you right now, this is the one I took out of the stripped hole because it's got little, it looks like clogged threads, but if I turn them carefully, I can actually get the little rings of aluminum to fall off in my hand, indicating that yes, indeed, this this screw pulled out the threads in that assembly. The question is this the proper screw to be in there in the first place? The reason why I ponder that is because I only have one screw with machine threads on it like this. All of the other screws I've pulled out so far that are unaccounted for, let's double check, but yeah, I'm pretty sure they're all this kind of thread, type for screwing into plastic. So did somebody just go ahead and decide that they were going to wrench these suckers in there because the other ones had pulled out already? I don't know. I'll have to look on the parts list and see what the parts list calls for. All right, I just threw them threw those screws in there tight as I can get them, so I can get the recoil on here, so I can give this a good pull. About 130 psi. Not sure on a 4-mix model like this how many pulls you're supposed to give it before you take the reading. Well, I Googled it to try and find the spec for the actual compression on one of these BR600 blowers, and it turns out it's almost impossible to find an actual number because Stihl, for the most part, doesn't even believe in compression tests on these things. They want you to do a like a leak down type of test with special tools and things like that. So the other problem is apparently there is some sort of a compression release on the cam to help aid in making the starting easier, which is going to also cause the compression to generally be lower. So with all that being said, the fact that I still can get compression out of this makes me think that maybe there's enough compression in there for this thing to start, and that maybe I should just ignore all that weird oil in there and ignore anything else, and just try and replace the fuel lines and see what happens. Maybe I'll take a peek in that carburetor to see what that looks like. But again, if I give it one good pull, I get what appears to be 75 psi, which is very low, but if I give it a couple more, it's 95. Is over 100. So if it had really low compression, I would be worried about a catastrophic failure inside the engine that may have had occurred. I really think I want to give this thing a shot. Another quick check I decided to make right before I go and order any parts is to see whether or not I've got any spark, and that's pretty easy to do. With the wiring harness disconnected, it's basically in the run position. The wiring, the way the ignition switch works is when the wiring harness is hooked up, if the switch is in the on position, it essentially grounds this terminal. It completes the circuit from this terminal to this terminal. This terminal is clearly a ground. So basically, if I ground this to this, that's the kill position. So with this disconnected, it's hot, and I can see that I've got a spark there. It looks like a nice blue spark too. I'm tempted to take a look at the valves and adjust the valve clearance. The problem is, if I open this cover up, I'm probably going to need a new gasket that goes underneath the cover and a crush washer that goes underneath this little bolt right here. And I looked online and tried to find the clearance for these valves, and I couldn't find an actual number in thousandths of an inch or millimeters for the clearance on these valves, because Stihl sells a little kit that actually has a special feeler gauge that's the right thickness, and it actually, the intake and the exhaust are set equally, and it actually is cut and shaped in a way so that it fits in there in this small area. And I believe the kit actually comes with a replacement gasket and crush washer, so if you're going to do the valve adjustment, you're just better off buying that little kit. It's not that expensive. It's going to give you the tool and the gasket and the crush washer. So I'll see if I can't find one of those. And if it's dirt cheap, I'll probably order it at the same time that I order the replacement lines. That way I can do a valve adjustment before I put this all back together. I decided I'm going to try and go and get just some generic line, fuel line, to replace these lines. And so I needed to get some measurements here. So I took the two lines off, and they are different sizes. The OD on the larger one is 0.215 or thereabouts. The ID is 0.170, and the way that I got that is I actually took a measurement. The nipple that it goes on the carburetor here, it's got a neck right there that's the smaller diameter. So the idea is that it would stretch over this nipple and then go over these rings to lock in. So I actually want the ID to be the dimension of that smaller diameter in the neck. I don't know if you can see that or not. Okay, so that ended up being 0.170 on the dot, and then the OD on the smaller line, 0.2112. Again, OD not as critical, except maybe in a couple areas where it might go through an opening, but some of these openings look pretty big. I don't think that's going to be an issue. And the ID is 0.119. So I finished taking several measurements the best I could, and I've determined that, well, first off, there are 3 basic sizes of fuel line available for all types of gas trimmers and weed eaters and chainsaws and that. And the 3 basic sizes are metric: 2mm ID, 2.5mm ID, 3mm ID. And then in the 3mm ID, there's 2 choices. One has a larger OD than the other. I'm not so concerned about ODs here. It's mostly IDs. I also took some readings in thousandths, and it looks like what we've got is the 1/8 inch ID line, which is 0.119 roughly, is actually 3mm. So it looks like I need 3mm for the larger. Interestingly enough, that 3mm ID has to stretch quite a bit. I don't know if you can see on this piece that I cut off, this was really stuck on the carburetor. This goes on the nipple of the carburetor, which is, the nipple is closer to 4D. I'm sorry, 4mm OD. I also noticed when I took this off, it broke right here. So that makes me think maybe these lines are original or old, whereas everything else on this is starting to look more and more like it was just very recently replaced. Note the condition of the gasket here on the carburetor, for instance. Definitely a cheap aftermarket gasket. I want you to note particularly that there is a ghost outline here. the actual diameter of the hole in this gasket is not as large as the diameter of the actual orifice on the carburetor. So that is not good. We're going to have to rectify that. Doesn't line up so great either, but my main concern is the fact that this is going to be choking that down. So that's not good. And the funny thing is, this whole carburetor may very well be a new... Yeah, I mean, this does not say Stihl on it anywhere. Or Zama, the other carburetor I found on Stihl products, which is leading me to believe this whole carburetor is a brand new Chinese knockoff. Okay, interesting. This gasket, the diameter of the hole on this gasket's a little large for that side. I wonder if they got these backwards. Well, maybe not. I'm gonna see right there. There's a little indentation. Is that a port that is completely blocked off by this gasket, and there's an indentation there now? No. Upon further examination, I can see that is actually an open hole. So that may be a port, and it is not blocked by the gasket. So. And the fact that that hole lines up with that port means that this must be the gasket that was supposed to go on this side. It's just got a problem with the diameter here, so we'll fix that. All right, let's go run and get some fuel line. Hopefully my local auto parts store has generic line for trimmers and stuff, and then I can get back to this this repair immediately, as opposed to having to wait for an order. And by the way, if you go on Amazon, you can buy like 20 feet. It's an assortment. They give you 5 feet of each of the 4 major sizes of trimmer line for like dirt cheap. And when I say dirt cheap, I mean like, you know, $12.99, and it would be free shipping because I have Prime. Although I may want to treat myself to the Hitachi 20-foot assortment there, because it comes with colors. So I went to my local Napa, and they have various fuel line by the foot, and this is 1/8 inch ID, which appears to be perfect ID for the smaller of the two, I believe. Or the larger, and then the other one, it's not quite right, but then the other sizes they had didn't look good. I think the larger one here might actually be the 1/4 inch ID. I'm sorry, not 1/4 inch ID. I'm getting this all messed up. This might be 3/32. And then I think I need 1/8 inch ID with a smaller OD than 1/4 inch. I don't know. Well, we're going to try and make this work and see what happens. Before I forget, I'm going to take this X-Acto knife and I'm going to trim this gasket to the right size. That's how it looks after I trimmed it. So I ended up removing that much gasket material. If I wanted to get picky, I could take the dimensions and I could actually calculate how much of a percentage of this was restricted. But who cares? The point is, it shouldn't have been that small. In a situation like this, where I don't know the history of the machine and there's clear evidence that it was recently deassembled and reassembled by somebody who didn't quite know what they were doing, I tend to want to ignore the positions of the fuel lines, because if I just put this all back together exactly the way I took it apart and one of these lines was incorrectly installed, I'm going to end up having all kinds of trouble. I'm going to be chasing my tail. So what I do is I just go back to the basics. The way that a system like this, a 2-stroke system that has a remote primer bulb like this, the way this works, this primer bulb is designed to actually suck fuel up out of the tank through the carburetor. Okay? It does not pump fuel up to the carburetor. All right, so what I mean by that is this line right here on the carburetor is actually the fuel inlet line. This is where the fuel goes into the carburetor to run the engine. This line is going to run down to the tank, to the nipple on the tank that is going to be attached to a line inside the tank that goes to the fuel filter or the fuel pickup. And I believe in this model there may be two, one on each side of the tank, so that as the fuel level runs low and the backpack gets tilted back and forth, it can still find a way to draw some fuel. So anyways, the point is, this line does not go to the primer. We're not trying to pump fuel into the carburetor. What actually happens is this other line on the carburetor right here, this little one right here, is actually, it's a vent that they actually run a line from this over to that primer bulb. And it goes to the side of the primer bulb that actually creates suction when you pump the primer bulb. So I've got a little piece of line on my primer bulb here. So obviously we're going to inspect the primer bulb, make sure it's not all dry rotted and cracked. This looks pretty good. It may very well be a newer primer bulb. And when I press it, you hear that noise there. It's a good indication that the check valve inside the primer bulb is working, because the way this bulb actually works is when I push on this, it's going to push out pressure from one nipple, but when I release, it's going to close a check valve, and then that's going to create a vacuum on the other line, and it's this one. So I know this is the vacuum line. If I push this bulb down and I put my finger over this, okay, actually I don't know if you heard that or not. I'll do it again. Push, block, release the bulb. That's actually pulling on my skin on my finger a little bit. So this is the line that's going to give me the suction. This short line, you have to make sure it's on the correct nipple so that you get suction on the release of this bulb. This line's going to go to that vent tube on top of the carburetor. So what ends up happening is when we pump this bulb, what actually happens is this is going to suck on this line, forcing fuel to be drawn up from the tank through this line and through the fuel filter. And once we get fuel coming back down and visible inside this bulb, we now know that fuel has gone through the carburetor and the carburetor is primed and ready to go. All right, so now that we know which lines are going where, as far as figuring out the routing of this whole thing goes, this one here that's going to go up to that vent line on the carburetor actually has to kind of make a tight turn, and there's a little indentation here which actually helps this sit in here like that and go to that carburetor like that. So if I take this part right here, it's going to go into there. So this is going to have to go in there like this. And then this mess kind of tucks in here like that. I've got those holes lined up. That's exactly how that should go. And the line's not kinked because it's got that little cutout in the plastic there to help make that sweep. This line, you can clearly see now when this is in this position, that this line wants to sit in this channel right here, okay? And it goes in this middle slot. I call it the middle slot because there's actually other slots down here. So there's actually 1, 2, 3 slots, but this slot is for the electrical wiring. This one is for this line that's coming down here now. So it's going to go in here like this, in here, and then eventually down to the tank. Okay. The other line from the primer bulb, okay, that line, which is the return line to the tank, actually goes through this hole right here. And then it goes onto the nipple, and then it's going to come down this channel right here like this. So now that I look at it, it occurs to me probably should have put this on first. Onto the nipple, it's a lot easier to deal with it that way. So I'm going to pull this back out. And by the way, it's also a lot easier to put this on by just popping this out. Pop it right back in. Okay. So far so good. All right, so I got this loop on the end here because I didn't end up, I got one long piece of hose that I bought at the auto parts store because I haven't cut this yet to size. I'm going to wait until I get this mounted in here so I could see exactly how much I need to go to the tank and cut it just right. I was also able to discover that the screw that goes here actually is the screw that's supposed to have the little bushing on it, the little step-shaped bushing, and the bushing actually goes between this white plastic piece and the orange plastic piece underneath it, and it faces up. So it actually goes in from the underside of the orange plastic, and then there's a 24 millimeter long self-tapping screw that goes in here. So I was able to make sure I got the correct screw in there, and I know that that bushing didn't come out of here when I was taking it apart. I'm almost positive that I found that over in one of these holes here. So we'll get to that momentarily. But by pulling up the parts manual and just looking at the parts list where they actually give the dimensions and the type of screw, I can actually make sure I put the screws in the right place, and more importantly, I can make sure that this screw, which is the only one that has not a self-tapping but a machine thread, is located in the correct place. Now that I have this assembly in, I can route the on-off power cable. There's an indentation here, kind of gives me a guide to the fact that that was under there. And that was under there, and then there's a notch right here in the plastic. This goes in the notch like so. And we got two connections here. Alright, a moment ago I had this routed underneath here by mistake. This little indentation right here is for this to happen like that. Okay, so now I'm going to reinstall the fuel tank, but before I do, I want to make note of which of these two nipples is which. The one on the right is the larger of the two. That's the one that actually goes to the fuel filters, and that's actually where we want to pick our fuel up from. Now, you can actually test if you've got good fuel flow. If you've got fuel in the tank, if you put a piece of pipe on this nipple and you gently blow into here, pressure should build and actually cause fuel to come up through this pipe right here, this little nipple. This device right here is a vent, and this is to help with changes in, I think, barometric pressure, or maybe as the fuel level drops to even out the pressure in the tank. So if this becomes defective, you can have a problem where the unit will run for a certain amount of time and then stop, starve for fuel. And if you find that by opening up the fuel cap and letting air in and closing it, that it rectifies the problem, chances are this is your culprit right here. Alright, so I cut the lines to what I feel is a good length. Gives me just enough length to reach in here and get these onto the two nipples, and at the same time not have them too long so they don't kink when I put it back in position. But what I'm going to do now is, now that I've got the two lines hooked up, I'm going to pump the primer bulb, and I should see fuel start to come up out of this tube, out of this tube here, fill this primer bulb, and then start to come back down into the tank here. There we go. Fuel's coming in. That probably right there is primed enough to start it. So now I'm going to move my tank into position, put the two screws in that hold the tank down, and then we'll put this other shroud on, put the spark plug in, put the recoil assembly on, and now let's see, whatever else I need to do before I can start this thing. I almost forgot to put my spark arrestor back on. I would have loved to have taken this muffler off to shake out any carbon that might be in there and see if it's blocked, because a blocked muffler can be a problem on these. The problem is the screws are recessed down these holes. I don't have a Torx driver, I don't think, that particular size, long-handled. Even if I did, apparently these are known to seize into the head here, so They can be very difficult to remove without breaking. Matter of fact, a lot of the people online I've seen work on these are actually grinding these, cutting these mufflers open essentially to get them off, and then removing the studs, what's left of the screws, and putting on a new muffler and new screws. And I really don't want to do that right now unless I absolutely have to, so I'm going to leave that alone. I hope for the best there. Well, unfortunately, I've got this thing pretty far put back together, and I've come down to the question of what screws go where, to be sure. And the problem I'm having is that according to one of the few manuals I could find online that showed the recoil assembly, it only showed one of the screws, and it called it an M518, okay, spline screw. Well, I noticed that in other parts of the manual, where it refers to these screws right here, it calls them M518, which these are 18 millimeter long, M518 self-tapping screws. These are the same screws that are used in the blower housing assembly to put that all back together, and in a couple other places where I already reinstalled them. So at first I thought, okay, so it's 3 of these is what holds this on. But then when I looked at the manual and I saw that, it said no. It said M518, and it did not say self-tapping. This is an 18 millimeter long screw. Yeah, this is probably 5. So unfortunately, I think what's supposed to hold this recoil assembly on is 3 of these. I only have 1. So I don't know where the other 2 originally went. I'm wondering whether or not somebody substituted these self-tapping screws because the holes were stripped out. To make matters worse, I also have this screw, which is a 20 millimeter self-tapping screw that I have not found a home for, and this screw, which is a 24 millimeter, even longer. So these 2 self-tapping screws I don't have a home for. So what I think is, I think these 2 go into the ones that are recessed way in here to hold the bottom of this shroud in position. I don't know why one is longer than the other. I can't find a manual online that shows a view to tell me what size screws go in there, because the only manual I can find online is E-Replacements, which is judging by the fact that all the prices are in like British pounds or something. It's a European website. I'm not quite sure what's going on there. And then, like I said, I think these 3 are what were in here when I took this apart, even though they're the wrong ones. And then I do have, again, also this situation here where there's this bushing, 2 bushings, and we're missing 1. I did have that other bushing, but I did find a place for that where I think that belonged over in that air housing assembly. So I don't know, but I know this goes in like this. So let me see. All right, so I'm more than convinced now that it's supposed to be the machine-headed, the machine thread screws, or the 5 millimeters, are supposed to be the ones that go in here. I was able to get one of them to go in, the 5 millimeter to go into this hole, and then on these 2 right here, they're stripped out. So I put in the 5 millimeter self-tapping screws and just snugged them up. And this seems like it's tight enough that I think I can probably, I wouldn't want to rely on it like for long term, but I should be able to at least make a start attempt. And if everything else runs perfectly and I end up having a problem with this down the road, then I would probably drill those out, next size up, and tap them to the next size up that I can, hopefully there's enough meat left on that casing to do that. But for right now, why don't we take this thing outside before it gets dark. It's starting to get a little dark, and give it its first start attempt since I've owned it.